Hey everybody, Dave here from Dave Tries to Fix Stuff, a channel dedicated to the repair, restoration, and resurrection of broken stuff. Today's episode, we are going to be taking a look at this little guy right here. This is a little tube amp head that I put together from the parts of other amplifiers. It is an Epiphone Valve Junior based amplifier. That's where I got the board from. It has been I'm not going to say extensively modified, but definitely has had some modifications done to it to try to change the tone of it quite a bit. Obviously, this is not a Valve Junior head. This is from a small Fender amplifier, and I will definitely go through what I did to get this thing mounted in here. The issue with this thing is that I was doing some modifications to it, and after the last modification I did, it has almost no output. I think it's going to be a fairly simple fix here. I mean, I know I always end up jinxing myself when I say stuff like that, but I truly believe this should be a fairly simple modification because of where the actual problem with this lies. With what I was doing to it when it stopped having the output, so I think it'll be fairly easy to fix. But we will go through the repair I do to that. We will go through the modifications I did to the board. We will go through what I did to the amplifier cabinet to get it to fit all this stuff in here and to have the smaller profile like it's got. What I did to make this beautiful faceplate, which is, I'll admit it, it's kind of hokey, but it does the job. So, but we'll basically go through everything I did to get this amp to where it is right now from what I started with. So, if you are interested in seeing what I did to put all this together, and you want to see if I could actually get it fixed and working again, then by all means stick around and we will figure it out together. Okay, so the first thing we're going to do is I will go through, not go through, but I will actually put my guitar through this, and you can kind of hear what it's doing. What I talk about when I'm saying there's a loss of signal, and you can kind of get an idea of what needs to be fixed on it. Right now I've got it plugged into my speaker that I did over there. You can kind of see the have it on 8 ohms because this is the output for this is 8 ohms. But we will get this turned on and be able to listen to it and figure out what needs to be fixed. So let's tighten this thing up here. It's my excellent camera work. We can switch it on. Bait here. I'm going to turn it all the way down. That's the other problem too, is I got to tighten up this. You can see that's supposed to be all the way down on the pot there, but I can still turn it more because the pot's not tight. So, but this is what it sounds like with obviously the volume down to 0. I'm just giving you a bass line so you can kind of hear the guitar acoustically, and then we'll turn it up. Now, it's at 7. Obviously, if I go above 7, you're getting that feedback right there, which is something we have to look at as well. But at 7 right there, this thing should be screaming. And, I mean, this sounds like what it should be sounding like down on like 2 or 3. So, there's definitely some stuff that needs to be looked at in here. But just wanted to give you the baseline as to what was wrong with this and what it was doing. So that needs to be fixed, and we need to get the output cranked up a lot more than what that is. So, alright, so we'll be right back. Okay, so the first thing we need to do, let's get that unplugged first of all. Then we need to start getting this thing taken apart. And oops, we can get that's the speaker there. You can see, and I'll try to kind of go over this as we get it taken apart. You can see what I did was I made a secondary chassis, and I'll go over it a little bit more as far as why I did everything the way I did it, plus a couple of small mistakes that I made along the way as well. But I do have a secondary chassis in here, and all the stuff is mounted up to the faceplate up there. So let's just start getting this thing taken apart. Okay, so as you can see, I've got everything taken apart now out of here. This was initially, we're going to just start off with the cabinet. We'll get to all this stuff first. I'm going to kind of go over what I did to get this thing kind of built. This was a cabinet from a Fender Frontman 15G, which is a little solid state amp. And it was about probably, I don't know, about twice as tall. It was about, this is about how big it was when I got it. Maybe not quite that tall, but it was like a little combo amp that had a speaker in the front of it. And that would, in fact, I have other videos where I kind of not featured, but I pointed out the board that I used to have in this thing. And what I did was I took the board out. I figured the whole reason I got it as part of a trade, and I thought, it's not a great sounding amplifier for what it is, and maybe I could utilize, I like these little amplifiers because they come with the corners, and they come with, usable pieces on them. And I thought what I might do with this one is actually use it to create a little head. And the idea was, and I did it very simply. I didn't want to, take all the Tolex off it and cut it and recover it and all that. So all I did was I just basically, you can see here that it's got a line right across here. Let's get the light on this a little better. And sorry, it's up at the top here, but you can see it's got a line going right across there. And obviously the same thing on the other side too. Same exact thing. A little line going across. All I did was I set up my table saw to cut this thing. I set it on its side, and I set the width between the fence. I obviously took all this stuff off. It was just the wood with the Tolex on it. Set it up to have the fence cut right at the width of what this bottom piece is. So when I set it through, it cut it directly right across here. Did that on both sides. Then I went through and I cut out a piece, about this wide on it, to where it took it up to this point. And then all I did was I just re-glued it at the at the seams, and I believe I tacked it too with like some brad nails right at the bottom, and clamped it and tacked it. And when it ended up drying, this is what it gave me. It was just this little thing that's about the size of a little amp head. The idea from that point was to set that out of the way. Was to utilize the chassis that was in there to make a to mount a tube-based amplifier. Problem is that the chassis on this is not the full chassis, but it's close. I don't remember what the reason was that I had for cutting this, but I did cut it. I got a Dremel tool out, and I cut this. What used to be a solid piece all the way up here, but this went up against the top of the cabinet. There was nothing on the bottom. There were just these little things that actually connected to the back of the speaker baffle. So when I cut this thing out, I don't remember why I did it that way. I don't remember if I really don't. I left these on there because these are the actual these are actually tapped for the bolts for the handle to go into. So the handle on the top of the cabinet actually goes into these things, so those had to stay on there. And God, I don't remember what the reason was. The thing is that I probably would have been better off just leaving the entire plate, because if you ground this, the whole chassis, then that provides really good RF shielding across the top. On the back of this, you can see that I actually filled in the back of this with just some JB weld. I just put a piece of tape across the front holes, and I filled in all the holes that were in here except for where I wanted the input, where I wanted this. I actually had 2 other holes because I was going to do 2 other. I think I was going to do a master volume and a tone control in these, and then I ended up taking them out because I was having too many problems with the circuit itself. And then I had the pilot light and the on-off switch, which is actually, these are the original pilot lights, and maybe that's not. Pilot light is not original, I'm sorry. On-off switch, I believe, is the original on-off switch that was in this. And I just utilized that by splicing it into what I had here. But I essentially, filled them in and made this my faceplate for this. Let's turn this around so you can see this better. The front of this, all I did in making this, you can see that there are like little bubbles here. This is dusty too, so it's kind of hard to tell. I live in Vegas, or I actually live in Henderson, but in the Las Vegas Valley, and it's always dusty here. So there's always dust on everything. So anyway, even with the dust off, you can see like these little bubbles in this, because all I did was I took a might be able to get some of that out. I just printed up I think I used Paint, if I'm not mistaken, just like Microsoft Paint, and utilized this is just a font, just a regular Arial font. I think this is Script, if I'm not mistaken. I made little, Ablex Instrument Control Company. Ablex is the combination of my 2 kids' names, and just basically made this little thing out of paper, printed it up. Then I got some clear packing tape and covered it, and then just worked out all the bubbles that were on here originally, and it has since obviously come off. So I should make a new one that's better, but. And then I just basically taped this on here where it went. I measured everything off and printed it so that it matched up, and then taped it on there, and it works great. So, but and then I have let's widen that back out so we can see what we're doing here. And then on this, I just have some holes where I have some grommets installed here, where the stuff that I need to attach from the board underneath here, I just had set wires to it so it can get to everything it needed to get on this little, faceplate / control panel. So, as far as this thing is concerned, this is just a piece of plate steel that I had that I cut to size. And then all I did was, you can see the shape of it right here. It's just like a kind of a U shape with some lips that I put on it, little edges. Obviously I should have made that one a little bit bigger, but it was enough to drill some holes in so that I can, drill it down to the bottom of the cabinet. I utilized the transformer, the original transformer from the Valve Junior. This is the power transformer. This is a transformer I picked up from Musical Power Supplies on eBay. The guy has these things made to his specs. I think they're made in China, but they're good little power supplies. You can see how beefy this one is. This is just a little 10-watt single coil, 10-watt single-ended output transformer, and it's nice and beefy. It's got a lot of iron on there, so that's pretty good. Kind of going back to the cabinet real briefly. The front of this thing was originally the baffle. They had, this was the thing cut for the baffle. It had ports on it. All I did was I cut it out. First, originally I cut it too small. That was one of the mistakes I made, so I had to put some spacers in there. But then I just glued the whole thing back together, clamped it, and then took the grill cover that was on there and started to put it back on and restaple it. And It works great for a little, little front piece that goes on the front of it for more decorative purposes than anything. But because the holes are in here too, it also allows for ventilation through it to try to keep the everything into the tubes and all that somewhat vented, so it doesn't get too hot. Now, as far as what's underneath here, see, I'll be honest, I didn't build this thing. I sort of was putting it together as I went. Never really had a whole lot of experience with, let's see here, here we go. Never really had a whole lot of experience with how to place everything and all that kind of stuff. I knew I needed a couple of holes for the tubes. I know I needed to place the power transformer, the output transformer. I knew that they needed to be at opposite ends from each other. I knew they needed to be situated 90 degrees from each other, the two power transformers. That is one thing too. I should point out, if you look at this, the end of this, and how much space there is there, and how much space there is between the end of this and here, I didn't leave any room for on the cabinet to have the little brackets that you put in there, so I could put get a piece of wood to go across the back to kind of protect it, so the back is always open. But anybody that knows Epiphone valve juniors, you recognize the board. That's what this is out of. I made some modifications to it. I beefed up the resistors to some of the things so that it things aren't running as hot. Like there was this, I forget, I have to look at the thing again, but I know I upgraded to this one so I could get, I think this is in the power rail if I'm not mistaken. This is actually one of the dropping resistors, so I put, it was one that always gets fried in the original what is that? God, I'm getting sidetracked here. Sorry. It's one of the resistors that always gets fried in the original board. So I put this really high wattage one on here that can dissipate a lot more heat, so it won't get fried and baked and all that stuff. I've got let's see here. You can see I've changed values out all over the place on this thing. It's tough to tell. I've changed the values on this one, You know what I can do? You know what? Let's do this. Because what I did, the actual values that I think I put on this, it was a, what do they call it? I think it was the Billy Gibbons mods is what I basically did on it, which, Billy Gibbons from, yep, I do have that here. Okay. So let's, we'll move this out of the way real quick. This way you can get kind of a good idea as to what I did here. Let's see, do I have the original? Junior mods, Essentially what I think I did, these are made so that, back off just a little bit, so that the ones that are in black are the original values, and the ones that are in red are the ones that had to be changed out. So I think I had changed out obviously one of these things, I could tell, because I might have changed that out in the past though, because this board has been through several different, not several, I'd say probably 3 or 4 different amplifiers. I've used it on different things. I will have different values in there and how I did it. So the grid stopper I think was always 68. I think the grid leak may have changed. I don't remember at one point. I don't remember. But anyway, there's a couple of them in there that are changed that are still the original values, but they were changed at another point, and then I changed them back to this one. So this gets changed out to a 220 microfarad. This gets changed out to a 0.01 microfarad. This originally I think was actually in the originals. I think this was a 1 meg here, and there was a 1 meg here, and then they dropped that to 100K, 100K. I think that's what it was. But I completely took this one out. That one's now a 10K. So that's really allowing a lot of signal to go through. I removed apparently the, I don't know if I did all these. I removed the bypass capacitor on this. They added a 3 meg negative feedback, which I don't even think I put that in there, so that might not be there. They upped this one to 1 meg, which I believe that's originally a 220K. This one is originally a 1.5K. So they probably raised that to kind of tame it just a little bit. They probably added this to tame it a little bit too, because with some of these values, you probably had a lot of signal hitting this this power tube. So I might have changed that one too to a higher value to help tighten things up. And then it had some changes over here with this stuff. I don't remember all the things I did. I may not have followed this exactly. I may have, you know, experimented with some different values and all that. And one of the things I did do to try to help tame it, which is where the change that I made, which is when everything started to go wrong, was I was trying to I put a grid stopper here between the pot and the second stage of the preamp tube. And I put it right where the wiper, like right on the pot, because there really wasn't a better place to put it. So and it was right after that. I don't know if I overheated the pot or if I may have I don't know if I spilled some or you know, put on too much solder and had some solder, you know, short something out right there. I really don't remember. I'm not 100% sure, but I believe that if I take this pot out and I remove that grid leak resistor, then I should be able to get that thing working again and get that all situated, and we'll have regular, you know, the regular amount of gain and volume and all that. So that's where we're going to start, is right there on that pot. So okay, now looking at this thing, you can see I've got a shielded cable that I used here, which I don't think where is that hooked up to on the other side? I don't even remember. There's a white lead here that's not hooked up to anything. I don't even know if it's necessary to hook that white one up. I don't. Normally I cut that stuff off, so it looks like I've got the red. Yeah, I think that white. I put a bright cap on here apparently. Yeah, because I've got. So I've got a ground here where I put this shrink tubing on. The green wire in here is not needed because I had white, red, green. Which is I think this is a 3 lead wire. I had white, red, green, so the white is most likely going to be coming down to this right here, and that just broke off. I think that just broke off just now because I was getting some signal earlier. And then the red should be going to the wiper, and that's the return back to the lead. So what I'm going to do is I'm going to, hopefully I have enough lead here on this. You know, if I don't, then I'll have to splice in a new piece or something. But you know what, I'll splice. I'm going to cut all these out here, and you know, restrip the wires here. I'll leave the cap. I will remove this resistor. I will re-solder the white lead to this lug, the red lead to this lug, and then I'll have to redo the ground to the housing of this thing. I think what I'll do is, while I have this stuff unsoldered, I'm going to test this pot to make sure that this pot is good, because if it's not, if I did actually burn this pot, I need to replace it with a new one. So that's what we're going to do. So I need to get this stuff cut off of here, and then we'll see where we are after that. Okay, so what I did is I replaced the pot. The pot that was in here, it was a 500K pot, and the circuit actually called for a 1 meg. I'm not sure why I changed it to a 5K. I don't know. I may have thought that the tonal properties of the 5K may have been better. The 150 picofarad bright cap is still on the old pot, which I may put on that. I did get, you can kind of hear some of the problem that I have there. I did get this thing all put back on here and working. As far as the problem with this thing being like very quiet, that problem's over. This thing is now blasting, I might say. So here's the weird problem. This, and I've never experienced this before, so I got to figure out what the problem is. Can you hear that? This shielded cable appears to be microphonic, which you can hear as I turn it down. It gets a little quieter. Oh, and that's the thing too. Even with this thing turned down all the way now, there's still signal. Let me we'll plug this in. That's something else I need to do too. I'll get to that in a minute. But even with the volume all the way down, it's still, signal's still getting through. But when I crank, if I crank it, it's still getting it. You can hear oscillation there too. So something is looping. There's something looping in this thing. It's looping back on itself, which is causing oscillation and is causing microphonics in this thing. And I noticed too that if I touch this, I'm getting that. Part of the problem with that is the fact that this is not a grounded input jack, and I need to change that. It's something I should have done when I was working on this before. So I am going to change this jack out to an input jack that is grounded, in the hopes that that might help to alleviate our problem. Excuse me. In the hopes that that might alleviate our problem with all this noise and microphonics and all that stuff. But we'll see. So let me get the jack changed out first, and we will go from there. I tied the two things off together. These were the two leads from the input jack. I went through all the jacks that I have in here, and I don't have. I mean, I've got like a stereo one that's got some things, and I'm actually have to order a jack that has yeah, I don't have any. I have to order some jacks that have some grounding tabs on them, because none of these are grounded right now. But the thing is, I'm not so much worried about having the microphonics there when I have the guitar plugged in and turned on. First of all, the reason this is from what I understand, this is my understanding of this, is that whenever you have a shielded cable like this, the way these are made up is you've got however many leads you have inside. This one has 4 leads that are all insulated. And then you'll have one lead that goes in there that's not insulated, and all that is surrounded by a foil, a conductive foil, and then you put the black insulator on the outside. And if you were to ground the lead that's not insulated, that will in turn ground the foil and basically shield all this cable. The problem with that is that there will be inherent capacitance within that wire, that, you know, between the shielding and the other inductors in there, or the other conductors, I'm sorry, that the other leads that are in there, and that it'll essentially have it act like a condenser microphone, which uses capacitance too. You'll have to look up a condenser mic to see what I'm talking about. And this thing is actually grounded at the other end over here, right. Back off just a touch. This is actually grounded right there. With I've got the white is the tip, the lead that went to the tip. The black is the one that went to the ground on the other end, and then that is grounded right there. Now I'm wondering if part of the problem was the fact that because the sleeve on the jack that I had in there, the sleeve actually will also ground onto the chassis where this thing is, where it was mounted right here. It grounds on that, and there's a ground on this pot, ground from here, ground going back. I mean, all this stuff is kind of grounded together. So because of that, I mean, first of all, there's a ground loop in there, which I think might be part of the problem with that that oscillation that was going on. Because now when I believe if I turn it up, that oscillation is no longer present. And also right now I've tied the two ends off on this, so that is completely gone right now. So basically the lead going back in there is grounded. And now I can turn this up and turn it down all the way, both ends, with no oscillation, no feedback, no hum, a little bit of hiss, which is always inherent in that. So, but you can also see when I mess with the end like that, it's also, you know, it's giving us some signal pops in there and stuff. But with it grounded, you can't hear anything. So what I'm going to do is I'm going to attempt to actually cut the non-insulated lead at this end, taking the foil and all that, the grounding from the foil all the way out of the system at first. We're going to do that first, because right now all the foil that's in here that's supposed to be shielding this is grounded to the ground plane of, or is connected, I'm sorry, to the ground plane on the board itself. So if I disconnect it from this end, there will be no shielding in this. We'll see if, first of all, if that will help to alleviate the capacitance on this and help to get rid of the microphonics of the shield, of the shielding on this. And then if that works, I'll see what happens if at the other end, if I re-hook up the original jack back up and see if everything will work that way. So first thing I have to do is I have to cut that lead and then and see where we are from there. So let me do that, and then we'll see what we're getting from there. Okay, so I got the thing cut at the other end, the grounding lead, the shielding lead, I'm sorry, cut at the other end, and I've disconnected the leads at this end. I've also noticed that this has to do with like magnetic fields and stuff, but all depending on where the pot is in relation to the two transformers will dictate if I have any kind of interference, like buzzing and humming and all that. So, but right now I have the volume all the way down, so I can touch this and I have nothing, which is good. So if I turn it up a little bit, which is fine, but this thing is still a little bit microphonic. But at the same time, I don't think that's going to be as big of a problem. If it continues to be a problem once I have the guitar plugged in, then we'll have to figure out what's going on with that. But as it stands, the microphonics is really not a lot when something like this happens. This isn't a very common occurrence, but it does happen. When it does happen, there's really not a lot you can do about it. There's just capacitance because of the fact that it has to do with like the impedance of the input. It's a high impedance input and all that. And when you have stuff like that, you're going to get capacitance like that, and you're going to get microphonics like that. So, but if I get this thing hooked back up to a jack, and plug a guitar in, it should theoretically at that point clear up the microphonics. You're not going to hear it or notice it. So all right, let me get a jack back on here. Like I said, I don't have a jack that is grounded. What was the one that I had? I don't have a grounded jack in here, so that sucks. I'm not going to be able to have anything on here that will shunt the signal if I don't have anything plugged in, but I think this is the one right here. But once I get this plugged back in, we should theoretically be able to have another. We can plug in the guitar again and see what kind of signal we're getting. So let me get this put back on, and we'll see where we are from there. Okay, so I got the jack put back on here and resoldered. I don't know how easily you can see it, but I got the not only I got the white lead back onto the tip, but I also got the black lead and the lead that has the foil around it too, the non-insulated lead done up to the sleeve on this thing. And you still have Microphonics, but the good news is when I turn it all the way down, it's now completely silent, which is good. And when I crank it, well, that sounds like that's still a problem. Maybe it's not. Oh, you know, there it is. Okay, it was resting against the thing here. So, okay, that's why. Duh. Okay, so it'll have Microphonics. It'll have Microphonics when there's not really passing a signal, but when I do that, you're not going to hear it anymore. What you heard before was because the thing was touching against the ground plane on that, and that was causing a problem. So as long as that doesn't do anything while it's got a guitar signal passing through it, then it's fine. It's not going to be a problem. So if we got, let's see here, the two different ways we can do this. The first way is just by, I think is a simpler way. It's always been easier for me to do it this way. What you do is you take the voltage between the cathode and the anode and you multiply it times what your voltage drop was. Okay, and so we'll do that. 333 volts times 12.39 gets us that number right there. Then what we do is we divide it by the resistance of the bias resistor. So I'm going to divide by 297, and that gets us 13.89 watts. Okay, that so normally when you look into the RCA tube book, it's going to say that an EL84 or a 6BQ5, which is the same tube, is supposed to dissipate at around 12 watts. Those were, I believe that was for tubes that were made back in the 30s, 40s, 50s. Those they weren't quite as I know the guitarologist on YouTube likes to use the term robust, and that's a good word for it. They're not as robust. They don't have the ability to dissipate quite as much heat in the old days as they do today. And these are newer JJ tubes that I have in here, so I don't believe that this dissipation wattage is going to be a problem. So I think that should be fine. But let's verify this and see what I get if I do it the other way. Okay. The other way is to take, using, again, you're using Ohm's law here, is you take the voltage drop, which is 12.39, and you divide that by the ohms, or your resistance, okay? And that gives us 0.0417, or 41.7 milliamps. This is how we get our current. If you know what the voltage drop is, you divide it by resistance, it gives you your current in well, not milliamps, this is amps right here. But if you move it over 3 spaces to get milliamps, then it becomes 41.7 milliamps. So there's that. Now, to get dissipation, again, it's all about math. What we do is we take the 345 and we multiply that times the 0.0417 amps, and that gets us our dissipation there. Now you can see that there is a discrepancy here between the two values, 13.89 watts versus 14.38 watts. What I would do is probably split the difference on that. We'll say 14.38 plus 13.89 and divide that by 2. That didn't work. Again, 14.38 plus 13.89 equals, divide that by 2. So that's getting us 14.1, we'll say 14, we'll divide that up, watts. Everything I've read about these, about JJ tubes and about newer EL84s in general, tell me that 14 watts is a good, I mean, 12 watts is kind of, if you're not looking to bias very hot, 12 watts, it can be a good target. I know people that bias as cold as 10.5 because that is actually like 75% of what the max ratings are in the RCA tube book. But there are, I know, I've read that Dr. Z biases the EL84s in their amps at 14 watts, and they are very, happy with that particular dissipation. So I don't think 14 watts is out of the realm of being safe for this kind of a thing. So this being 14.14 watts, I'm happy with that. I have no problems with that. So I think this thing is actually dissipating at a perfect wattage. So I'm not going to worry about trying to change out the bias resistor in it. I'm going to keep it as is because I do like the tone. I was just the reason I wanted to check this is because when I was looking at the tube and it was playing, it seemed like it was red plating, but it may just have been the glow of the heating elements in there were just really glowing, because this is really not anything near where red plating would be. If this is up to like 15, 16, maybe 17 watts, I would see red plating on there. But it seems like it's okay, and I don't think this amount of wattage, this amount of dissipation will shorten the life of the tube. So I'm good with that. The next thing I'm going to do, I've decided, and I did order them already. Let's move this back into the picture so you can see here. These two components right here, this potentiometer and this jack, input jack. I said it again, this is not a shorting jack. This is just a regular mono jack. And because of that, if there's nothing plugged in, with the fact that I've got this microphonic shielded cable here, that will and if this thing is on and there's any volume at all on this thing, you're going to hear all the movements that are happening on the amp. That if you tap the faceplate, all that stuff's going to come through and broadcast over the speaker. So I want to get a shorted or a shorting jack in here, so when something's not plugged in, it's going to shunt the signal to ground, and it will eliminate all that noise. And I've proven already that when I have a guitar plugged in here, that Microphonics goes away, and just the signal from the guitar goes through. The other thing I'm changing is this potentiometer. I've also ordered some logarithmic potentiometers at 1 meg. I will remove this cap here and put it on the new one, but because of the fact that all of my volume is coming between completely off and 9 o'clock, which is about 2.5 on, out of 10 on the dial on this thing, all of my volume comes in that little section. So this linear pot is not going to work. This linear pot needs to be taken out and an audio taper pot put in its place. And once that's in there, it will be able to use the full range of the whole pot, so I'll have a lot better control over the volume on that. So those will be coming in the mail hopefully within the next couple of days, and once I get them, I will install them, and we will do a final video showing a demonstration of the amplifier. So when I get those things in, I will be back and we will continue. Alright, I just wanted to show real quick the cabinet for this thing. Well, I'm waiting for those parts to get delivered here. I use some, I've got regular shielding tape that's just, silver colored, that doesn't have any writing on it, but I couldn't find it. But I bought this 3M tape a while ago. I think this is meant for like insulation and stuff, to seal insulation. But it will actually hold a current. So when I have everything put back in here, this should provide pretty good RF shielding for the whole thing. It's just unfortunate that from the back you are going to be able to see it because of the fact that I have nothing on the back to cover this thing up. But oh well, it's still going to be a nice amp once I'm done with it, but I just wanted to show that I got all that put in there. So okay, so it's about a week later now. It took a little bit longer for the stuff that I ordered to arrive than I had anticipated. It did come during the week, but just between work and all the other stuff I had going on, I just wasn't up for working on this thing. But it is now my weekend, so we can get going on this. Anyway, so I've got, in addition to several other parts that I've already put away and where they're supposed to go, I got my potentiometer here that I need, 1 meg, logarithmic. I got a shorting jack here, and this was the knob that I wanted to use on this. That should, theoretically, yep, goes right on there perfectly, so that's good. Alright, so let me get this stuff disconnected and reconnected to the new parts. We'll get them installed and we'll see how they work. Okay, so instead of hunting down all the stuff I need, I found my guitar cable and had my guitar and all that, I thought I would try out this signal generator that I recently put together and see what that gives us. So I have it hooked up, I have everything down, the volume down to 0 on the thing, so let's turn up the volume and see what we get. Now, I know that's kind of tough to see, but if you'll notice, the volume goes through the entire sweep of the potentiometer and not just the first quarter of it, which is how it was on that linear. So this is definitely fixing the problem that we had on this. Now, the other problem I'm seeing is the fact that this is still grounded, because of the fact that this is all there. So a lot of the signal's going to ground right now. So I'm going to put this guy in here to separate out the tip from the shunt, in the hopes that we can clean this up a little bit. So turn it down. Let me put this in here. Now you can hear it because it separated it. So it's loud now. Let me turn it down. It's definitely loud. So that's the thing though, is this is getting an active signal, so even at the lowest, it'll still, if I turn this all the way up, you're still going to hear some signal going through because this is an active signal. I don't know how it would be compared to active pickups, let's say, how hot they are, but this is a pretty hot signal coming through here, so. I mean, so hot that it's like, giving it much of anything, it's gonna right there. I mean, just barely lifting this thing, but it still is at least going through the entire sweep of the potentiometer, so that's a good thing. So we know that works. So let's disconnect that, and we will disconnect that. Oops. I can actually unplug this. And then put this back here for a moment. And the other thing I wanted to test is I want to turn this all the way up. And the microphonics are now no longer present. I can hear the hiss in that thing, but even if I touch this guy, it's actually no longer, the microphonics are gone because the signal is being shunted to ground. Let's see if I put this back in here. There. I separated it and it took the hiss away, but now you've got the microphonics are back. So having this thing shunt that to ground takes the microphonics away. So this is good. So this is basically done what we wanted to do. So let me get this put back into the cabinet. We'll get everything buttoned back up, and we'll see how it sounds. All right, so I got everything buttoned back up. There is something squirrely about this that I may, and I'm not going to mess with it right now because I'm not really concerned with it, but it is something that is happening that it really should not be happening. And I think it has to do with not the bright cap, but the mid push cap that I put on the pot. And I'll tell you what I'm talking about. I'm gonna hit a chord. Now, I don't know how much that is like a whoosh that's going to be present as I turn it up. And I don't know if it's going to be able to be captured on the camera, but I think it will. But let me go through it. Let me hit a chord and kind of turn it up and see if you hear this whoosh. Can you hear it right there? And like I said, I think that has to do with the pot, or the cap I put over on the pot. So I'm gonna have to figure out what the problem is. I might end up having to cut out that cap and kind of just go with it. I like the additional push it gives in the mids on this thing when this thing is maxed. So what I may end up doing, if nothing else, is I might put it on a switch, which, hell, I don't know where I put the switch on this thing. I mean, I could theoretically do a push-pull on this, but that means having to order even more potentiometers, and I'm not really into doing that right now. But if I put the mid push on a switch, I might be able to alleviate all that. So if I keep the switch pushed in, I'll get just normal, and then if I want that extra punch, I can pull it out at the volumes I want and hopefully not have that feedback real bad. So, but aside from that, let's hear what it sounds like. Jumbled mess, but it does have some really good crunch on it. I mean, this is cranked, obviously, but I mean, I love the sound of this amp. Listen to that sustain, and you can't even hear me, I don't think, when this thing is belting like that. Can you hear me talking? If you can, it's crazy, because I can barely hear it. This thing is friggin' loud, so I'm digging it. This thing sounds awesome. I mean, it looks like a Little Fender, but it doesn't sound anything like a Fender, so it's got some boss. So I'm digging this amp. I like the sound on it. I will need to work on the eventually on the mid cap, and I'll get that. I mean, worst case scenario, it's a matter of cutting it out, or finding another another value that's going to do what I want it to do without getting the feedback and the whoosh and, you know, all that kind of crap. This is a really cool amp, and I'll tell you what, it does scream. I could probably, if nothing else, I can rehearse with this with the guy. If this is the only sound I wanted, I'm not going to get much in the way of clean sounds on it, that's for sure. God damn, it's a kick-ass rocker amp. This thing sounds really good for that. So this will be a one-trick pony amp, but I don't care. Anyway, we got everything accomplished on it, so chalk another one up to what I'm going to consider a success. It can be another project that I can do at another time when I feel like messing with that cap on there and getting all that fixed. So anyway, that'll do it for this particular episode. Click subscribe if you like what you see. Click a thumbs up if you like what you see. You can leave a comment below, even if you think that there was something that I did wrong or have suggestions or something like that. By all means, I love to learn, so leave a comment down there and let me know what you think. Other than that, hopefully I'll see you guys next time. Thanks for watching.